hardware-based LED blinking project. Hello, Cloudemy welcome you all. After all my lessons, now I'm sure you will be aware of the very basics of Raspberry Pi. Now let's interact with hardware using Raspberry Pi 3 by creating a basic LED blinking project written in Python programming. You can also find the executable source code attached here with the lecture. For this project, we require the following hardware: 5 LEDs. LED stands for light emitting diode. It is a two-laid semiconductor light source. It is a PN junction diode which emits light when activated. It consists of two pins in which the longer pin is positive and the shorter one is negative. A breadboard. A breadboard is a solder-less device for temporary prototype with electronics and test circuit designs. In most electronic components, circuits can be interconnecting by inserting their LEDs or terminals into the holes and then making connections through wires where appropriate. 6 jumper wires. A jumper wire is a short electrical wire with a solid tip at each end, which is normally used to interconnect with the components in a breadboard. They are used to transfer electrical signals from anywhere on the breadboard to the input or output pins of microcontrollers. As now we are aware of our components, we will start assembling the circuit as shown in the diagram. First of all, make sure our Raspberry Pi is off so as to avoid short circuiting. In most electronic projects, everything that connects will require a common ground, as we have shown it with the green wires. Since ground rail connection is still half of the breadboard, we have to use a short wire to extend the ground wire to the next half. Here we are using pin number 6 as ground, but you are free to use any one of the ground pins available on the Raspberry Pi board. You can see that the negative sides of LEDs are connecting to the common ground rails of the breadboard, and positive are connected separately to the GPIO output pins 10, 12, 16, 22 and 26. With this, the assembling of hardware is over, and it's time to write Python program of the project. Import rpio.gpio as GPIO. To add the GPIO library to a Python sketch, you must first import it. Import time. This will import the time library. GPIO dot set warnings false. This will disable the runtime warning generated by Python compiler. GPIO dot set mode. GPIO dot board. The GPIO dot board option specifies that you are referring to the pins by the number of the pin, which is the numbers printed on the board. GPIO dot setter 10, GPIO dot out. This will enable pin number 10 as the output pin for first LED. GPIO dot setup 12, GPIO dot out. This will enable pin number 12 as the output pin for second LED. GPIO dot setup 16, GPIO dot out. This will enable pin number 16 as the output pin for third LED. GPIO dot setup 22, GPIO dot out. This will enable pin number 22 as the output pin for 4th LED. GPIO dot setup 26, GPIO dot out. This will enable pin number 26 as the output pin for 5th LED. While true, here we need to put the code inside a loop so that it continuously blinks the LED in on or off pattern. The code so far looks like this. A while loop is a control flow statement that allows the code to be executed repeatedly based on a given Boolean condition. Passing true as an argument in the function, run the loop infinite times to blink the LEDs. GPIO.output 10, true. GPIO.output 12, true. GPIO.output 16, true. GPIO.output 22, true. GPIO.output 26, true. Time dot sleep 1. This piece of code contains the main logic of the program, enabling LEDs to blink. So the LEDs will blink for a second because of the sleep function specified with 1 in the argument. Print LEDs are on. This will display the message on screen when LEDs are on. GPIO.output 10, false. GPIO.output 12, false. GPIO.output 16, false. GPIO.output 22, false. GPIO.output 26, false. Time dot sleep 1. This piece of code is disabling the LEDs from blinking, so the LEDs will not blink for a second because of the sleep function specified 1 in the argument. Print LEDs are off. This will display the message on screen when LEDs are off. GPIO dot cleanup. And finally, when all the operations are over, we are cleaning up all the ports used in the program. Now click on the file and save it. Give the file name as LED. No need to add the extension .py as it will be by default. Now click on the run and then run the module. We can now see that the program executes successfully. If you get error, try running as root. Then we need to run the program in super user privilege. Now let us test the program that perform as per our expectation or not.